Good morning. I'm continuing the explanation of Jeemain PYQ physics questions. Actually, starting from 2019 to 2025. So we have completed 40 questions. I'm going to continue with this with the rest of the questions. So that the topic is motion in a straight line. So let us move on to the question number 41. See here, water drops are falling from the nozzle of a shower onto the floor from a height of 9.8 meters. From a height of 9.8 meters. The drops fall at regular intervals of time. When the first drop strikes the ground, at that instant, third drop begins to fall. Locate the position of the second drop from the floor when the first drop strikes the floor. So, first we need to understand the problem. Water drops are falling at regular time intervals from a nozzle which is at a height of 9.8 meters. Here, regular time intervals is one keyword. By the time first drop reaches the ground, third drop is about to fall from the ground. That is another important statement. Then you have to find the location of the second drop or height of the second drop from the ground. From the ground, you are supposed to find the height of the second drop. Here, if you solve the problem, if you look into the hints given in any textbook or material, it will be this long, but you can just answer that question in 2 or 3 seconds at the most if you really understand the question and if you can understand the shortcut as well. So follow me very carefully. See here, water drops are falling at regular intervals from the nozzle which is at a height 9.8 meters. By the time first drop touches the ground, third drop is about to fall. So, second drop is somewhere here. See, in case of kinematics, in case of a body starting from rest, moving with uniform acceleration, ratio of displacements in successive equal time intervals is 1:3:5, so on. That is the magical concept here. So, the ratio of these displacements is 1:3. So, the total is 4 parts. 4 parts length is 9.8 meters. 1 part length is how much? So, 1 part length is 9.8 by 4. It is 2.45 meters. So, 1 part length is 2.45 meters. If that is in your hand, you can do anything asked on that question. Here the question is, what is the height of the second drop from the ground? So, height of the second drop from the ground is how many parts? It is 3 parts. So, the answer is height of the second drop from the ground is 3 into 2.45. So, 3 5s are 15, 13.35 meters. So, the answer not 13.35, 9.35, just 3 into 2.45, it is 7.35 meters. So, that is the answer. 7.35 meters is the correct answer. That is 2.45 into 3. See, actually you need not calculate that. If you take it as approximately 2.5, 2.5, 3s are 7.5, a little less than that, it is 7.35 meters. That is the answer for that problem. Now look into question number 42. A rubber ball is released from a height 5 meters above the floor. It bounces back repeatedly, always rising to 81/100th of the height through which it falls. So, find the average speed of the ball. See, first you have to imagine the scene. When a ball is dropped, it repeatedly bounces and finally it comes to rest. So, the total distance travelled by the ball before it comes to rest, let us take it as S, that is h into 1 plus E square by 1 minus E square, that we already derived in the synopsis. And similarly, the total time taken before it stops is T is equal to, or total time, let us take it as capital T. So, T is equal to, time of free fall is T, say, that is T into 1 plus E by 1 minus E. So, the total distance travelled before coming to stop is h into 1 plus E square by 1 minus E square. Total time taken is T into 1 plus E by 1 minus E. You are supposed to find out the average speed of the ball. So, average speed is total distance by total time. If you simplify that, you will be getting it as h by T into 1 plus E square by 1 plus E whole square. All these three formulae must be on your tips because we have learnt it in the synopsis. So, here if the average speed of a ball dropped from a height h which reaches the ground in time t before coming to rest is h by t into 1 plus E square by 1 plus E whole square, where E is the coefficient of restitution, E is equal to square root of h1 by h, where h1 is the height reached in the first rebounds, h is the original height from which it is dropped. It is clearly given, it bounces back to 81 by 100th of the height through which it is dropped. So, E is simply 81 by 100, that is 9 by 10, or E is equal to 9 by 10 is 0.9. Just if you substitute this in this expression, you get the answer. Height is given, but time of free fall is not given. So, time of free fall is square root of 2h by g, that is square root of 2, h is given as 5 meters and g is 10, it is a 1 second. So, time is given, height is given as 5 meters, E is known. So, the average speed before it stops is h is 5 and time of free fall is 1, 1 plus E square is 0.81 by 1 plus E 1.9 whole square. So, this is 5 into 1.81 divided by 1.9 into 1.9. So, this is approximately, if you take it as 2, this as 2 into 2, it approximately becomes equal to 2 in the denominator. So, 5 by 2, that is 2.5 meter per second is the average speed. So, here the most important formula you have to remember is when a body is dropped from a height and it reaches the ground in time t, before it stops, total distance formula, total time formula, and then the average speed formula, and then coefficient of restitution E is equal to square root of h1 by h2, h1 by h. Only when you know all these things you can answer that problem, but that is a simple problem because all of them, they are fundamental formulae. Let us move on to the next problem. Look here, read the problem. A bus moving on a straight road with a speed of 72 km/h brought to halt within 4 seconds after applying the brakes. Distance travelled by the bus during this time. See here, question number 43. The data given is u is equal to 72 kmph. If you want to convert that kmph to meter per second, you have to multiply that with 5 by 18. So, initial velocity is 4 5s are 20 meter per second, and it is halted, meaning it stops in time 4 seconds. T is equal to 4 seconds. What is the distance travelled by the bus before it stops? In case of a body moving with uniform acceleration, the displacement in terms of velocity says u plus v by 2 into t. Because in case of a body moving with uniform acceleration, average velocity is u plus v by 2. So, average velocity into time. If you make use of this formula, it is 20 plus 0 by 2 into 4. It is just 40 meters. So, the answer is 40 meters. Right? Now, let us move on to question number 44. The displacement and the increase in velocity of a moving particle in the time interval t to 2 plus 1 t plus 1 seconds is 125 meters and 50 meter per second. First, we should know what that data given is. See, the displacement of the particle in the interval t to t plus 1 seconds is, it is the displacement of the particle in the nth second, like t plus 1th second. So, displacement of the particle in the interval t to t plus 1 seconds is nothing but it is the displacement of the particle in t plus 1th second. So, in t plus 1th second, the displacement is given as 125 meters. And what else is given? The increase in velocity from t to t plus 1 seconds is 50 meter per second. So, increase in velocity per second is nothing but acceleration. So, acceleration of the body is given as 50 meter per second square. Then the distance travelled by the body in t plus 2th second. Now, in case of a body starting from rest moving with uniform acceleration, it travels an additional distance numerically equal to acceleration in every second. Suppose in the first second it travels x distance, in the second second it travels x plus a distance. Suppose in the 10th second if it travels x, in the 11th second it travels x plus a distance. That we know pretty much well. So, from that concept, if it travels a distance of 125 meters in t plus 1th second, what is the distance travelled by it in t plus 2th second? It is very obviously distance travelled by it in the before second plus acceleration. So, the answer is 125 meters. If you solve that problem, it will be this long. But if you have that concept in your mind, a freely falling body in every second, it travels an additional distance equal to g1 compared to the previous second. Any body starting from rest moving with uniform acceleration, it travels an additional distance a1 compared to the previous second or previous equal interval of time. Okay. So, based on that concept, it is 125 plus 50, it is 175 meters. See, if you can understand that concept, 125 plus 50, it is 175. That simple is the question. Now, coming to question number 45. A tennis ball is dropped onto the floor from a height of 9.8 meters. Rebounds to a height of 5 meters. Ball comes in contact with the floor for 0.2 seconds. Average acceleration during the contact. Look here. Question number 45. Ball is dropped from a height of 9.8 meters. It rebounds to a height of 5 meters and the time of contact is 0.2 seconds. Acceleration due to gravity is given as 9.8 meter per second square. Find the acceleration during the contact time. So, actually, if you take the velocity with which it strikes is v1, velocity with which it bounces up is v2, then during the contact, change in velocity is v1 minus of minus v2, that is v1 plus v2. Acceleration is change in velocity by time, it is v1 plus v2 by t. That is very obviously in the upward direction. Force is exerted by this on the ball. So, v1 as it has fallen through a distance h, from the formula square root of 2, g is given as 9.8 and h is also given as, no, g is given as 10 meter per second square. So, here g is given as 10, h is given as 9.8. So, it is root 196, v1 is 14 meter per second, v1 is known and it has raised to a height of 5 meters, v2 is equal to square root of 2 g and h. So, v2 is equal to 10 meter per second, v2 is 10 meter per second. Substituting v1 and v2 in this formula, what is acceleration? Acceleration is v1 plus v2 by t. Contact time is 0.2 seconds. So, acceleration is 24 by 0.2 or 240 by 2 or it is 120 meter per second square. That is the answer. So, acceleration v1 plus v2 by t, v1 is square root of 2g 9.8, that is 14 and v2 is 10, 24 by 0.2, it is 120 meter per second. That is the answer, right?